Good day once again. In the last series, I've shown you the history of early computers and demonstrated how the analytical engine by Charles W. Babbage can be used to write simple applications. In this series, I'm going to demonstrate how the same programming activities can be done in the IAS machine, a computer that was invented by John von Neumann in 1946. But before everything, I would like to explain what the stored program concept is all about. The stored program concept was invented by John von Neumann in 1946. To give you a little history, uh, the stored program concept was already included in EDVAC, which was the second project of J. Presper Eckert and John Moakley after the ENIAC. However, it was said that John von Neumann was initially part of the design team, and during the early discussions of the design aspects of the EDVAC, John von Neumann and his group uh, created a design together. However, in the succeeding periods, John von Neumann in 1945 released the first draft report on EDVAC, detailing the design aspects of the EDVAC computer. At the same time, he also invented or designed the IIS machine at the Princeton College. However, he was able to present the design of the IAS ahead of the EDVAC. He was able to release the design of the IAS in 1946, and that's why he was accredited to be the author of the stored program concept. What is the stored program concept? To illustrate this point, I would like to explain or describe the popular architecture before the invention of the stored program concept. In 1944, the Harvard Mark I was invented by Howard Aiken, and it was typical of the architecture called the Mark I or the Harvard architecture. Uh, the main problem with the Harvard Mark I is, aside from being mechanical, is the execution of programs is usually very time consuming. One aspect that was observed by von Neumann is in the processing of instructions, particularly transferring the instructions from the input device, which was IBM punch card at that time, was very slow. Uh, the Mark I architecture is typical of the design of the IAS. It resembles the IAS in certain aspects. Like in this case, the source code is solely stored in the Jacquard loom, or in the case of the Mark I, it is stored in the uh, punch card machine. And the variables are purely used to are stored mainly in the memory, or called some was then called as the store. In the IBM Mark I, the same concept is followed. The source code of the program is stored in the input device, usually an IBM punch card machine, reader and writer. And the variables are stored purely in the memory separately. And the problem with this is the execution of the instructions is usually time consuming. That is because the instructions run on a mechanical device, which is the punch card reader. So scanning each command one by one and going back and forth when branching is needed is very time consuming, in the sense that the punch card reader is a mechanical device. So the suggestion of John von Neumann is, instead of running the program from the input device, he proposed that the programs should be run in memory, which means that the program is either stored in an input-output equipment, is transferred from the equipment to the main memory before it is executed. That's called the stored program concept. The advantage of that is that the time-consuming process of transferring instructions into the CPU will be hastened because the main memory is primary electronic. And a radical change was introduced in the design of the CPU. In addition to that, John von Neumann proposed that the processor, instead of having to do everything, including arithmetic and processing instructions, should be divided into two main components. The first component is the arithmetic logic unit. In the past, the main processor does the arithmetic. In von Neumann's proposal, the arithmetic logic unit should be done separately by the arithmetic logic unit, where three registers were introduced. An AC, or an accumulator register, which is used to store one of the inputs during arithmetic operations. Consequently, after the arithmetic is done, the AC is also used to store the result. The second argument or operand in an arithmetic operation is stored in the MQ, or multiplier quotient register. It can store the second addend, the subtrahend, or one of the multipliers during arithmetic operations. And the memory buffer register is used to temporarily store the result before it's transferred to the main memory or to the accumulator register. On the other hand, a second component was introduced. It was called the program control unit. The task of the program control unit is to perform the conveyor belt that was present in the punch card reader machine used in the Mark I. So this is mainly used to control which part or command in the program will be executed. In the next video, I'm going to show you or demonstrate to you how the program control unit works, so that it's able to fetch and execute the instructions that are stored in main memory. See you then, and thanks for watching.